Sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Well, that matches this. There's a plus in here. It's sine, cosine, cosine, sine, which means you're using sines. You just have to recognize what your alpha and your beta are. Well, this t must be your alpha, and this 2t must be your beta. So we can rewrite this in terms of sine of t plus 2t, which equals sine of 3t. So your correct answer should have been A, sine of 3t. Any questions on that? All right, questions from the homework. Yeah, Grace. 51. 51 was kind of a tough one, particularly because, so in order for these to work, we have to have an alpha and we have to have a beta, right? Well, in that case, it kind of doesn't really have one. It has the start of 1. It gives you that you have the tangent of pi over 7 plus cotangent of pi over 2 minus pi over 6 all over 1 plus tangent of negative pi over 7 times tangent of pi over 6. And we want this to match up with tangent alpha plus tangent beta all over 1. Well, if I have a plus on top, I need a minus on bottom. Tangent alpha, tangent beta. It has to match up with that. You need to have just one alpha and one beta. Currently, it kind of looks like we have this as an alpha. Well, this is close to it. If they're both positive, that would be my alpha. Well, we can make the bottom one positive. Since it's tangent, we bring that negative sign out front, which will actually match this negative sign right here, Grace, right? Then I'll have that negative, it'll match up there. So my alpha would be pi over 7. The problem is our beta. Well, our beta here is pi over 6. But this doesn't say pi over 6. Not to mention it says cotangent. If I was on a test and I just had to pick a beta and I didn't have time to do any work, that has to be your beta. It has to be pi over 6 has to be your beta. But what actually makes it our beta? What makes it our beta is because using a cofunction, tangent of an angle equals cotangent of pi over 2 minus, maybe I shouldn't use alpha because we used alpha too much. Let me just say x. Because otherwise too many alphas going on. So tangent of x equals cotangent of pi over 2 minus x. Well, that's right here. We have that cotangent of pi over 2 minus that pi over 6. So you can take that pi over 6 and plug it in there. And so this is actually tangent of pi over 6. So your beta would be that pi over 6. And then you think you can do it from there, or do you want to do the next step?
You can do one next step.
Yeah. So once we know what our alpha is, our alpha is that pi over 7. Our beta is that pi over 6. So now we can reverse engineer this. This is just our tangent of alpha plus beta. So now that I know my alpha and beta, I can plug those values in. And then I would just simplify what's in there. So you would just do pi over 7 plus pi over 6, which if you do correctly would be 13 pi over 42. And then you just leave it that, because it's not on the unit circle, so you can't go any further. Okay, yeah, Birdie.
59.
59. What is 59 asking us to do? So 59 just asks us to do our cofunction. So the cofunction, they give us a secant, right? So they tell us that secant using cofunctions, So say we have secant of x would equal cosecant of pi over 2 minus x. Well, in this case, we have secant of 1. So that would equal the cosecant of pi over 2 minus 1. But looking at the right-hand side with a through h, there is no pi over 2 minus 1. So I'm going to simplify that by saying, well, 1 is actually 2 over 2. So we have pi over 2 minus 2 over 2, which is just going to give me cosecant pi minus 2 over 2. And that is f on there. Okay. Leo.
Can we go over 44?
Sure. 44 was sine of 165, correct? So sine of 165, there's multiple ways you could break it down. My hint to you was you could use 120 plus 45. That's one method that works. So if I stick with sine of 120 plus 45, well, it goes sine, cosine, cosine, sine. That's how sine, the sum of an angle works. So we're going to have sine of our alpha, which is 120, times cosine of our beta, which is 45, and plus, with sine, the plus carries over. Cosine, it changes. But then we'll have cosine of our 120 times sine of 45. Well, the sine of 120 is going to be square root of 3 over 2. Times the cosine of 45 is square root of 2 over 2. Plus, the cosine of 120 is actually negative 1/2. It's in quadrant 2. 120 is in quadrant 2. So our cosine of 120 is negative 1/2. The sine of 45 would be square root of 2 over 2. Well, square root of 3 times square root of 2 is going to equal square root of 6 over 4. Plus, well, that's all going to be negative, so I'm going to actually change that to a minus. 1 times square root of 2 is square root of 2 over 2 times 2, which is 4, which if we simplify is square root of 6 minus square root of 2 all over 4. Good. Awesome. Other questions? Yeah. 50 is just a cosine, cosine, sine, sine. So we just really need to recognize what our alpha and our beta are in that example. So let me just take a picture. So since it is cosine, cosine, sine, sine, I know I'm using a cosine either sum or difference of angles. But the first thing I need to do is I need to have 12 in both spots here. Well, that works. These must be my alpha. So when I do my cosine, that is my alpha, is 12 degrees. But here I have a negative 3 and a negative 3. Since they are both negative 3, you could have potentially just gone from there, but I just like to make it positive if I can. So the first thing I'll recognize is if you look at your odd-even functions, cosine of negative 3 degrees is the same thing as cosine of positive 3 degrees. You can get rid of the negative that way. You can get rid of it there. For sine, you bring the negative out front, which actually makes this a positive. Now I have a positive 3 degrees. Positive 3 degrees. So my alpha is 12. My beta is 3. Now I just have to look at my identity sheet to see which of my cosine sums has a positive between it, and it actually is the difference. It's the difference of alpha minus beta. So it would be that 12 minus 3, which is cosine of 9 degrees, which is on the unit circle, so that's as far as you can go. Because it says don't use a calculator. If you can't use a calculator, either it's on the unit circle and you can go further, or it's not on the unit circle, and that's where you have to stop. Does that all make sense?
Yeah.
Okay, good. Grace. 46. Do you have a specific question?
I don't understand
How to do the negative one?
Yeah.
So there's two ways you could tackle this one. So see how it's cosine of negative 75? You could just make it cosine of positive 75.
Oh, you can?
Yeah, it's just using the identities. It is just using those identities. But let's say, so real quick, so cosine of negative 75 degrees would just equal cosine of 75 degrees. Just like say you had sine of negative 75 degrees, one of the easier ways is just to make that negative sine of 75 degrees. And then you can just solve it all and just tack a negative out front and see how it distributes. But you can still tackle negative values. You can still tackle negative values. And my advice to coming up with those values is kind of start with 30 degrees. So let's say I'm just leaving it as 75 degrees, all right? Negative 75 degrees. I didn't do any of that. And I'm trying to break apart that negative 75 degrees. So one method you can do is what I'm kind of doing in my head is I would do something like 30 degrees minus what would give me a negative 75 degrees. Well, that would have to be 105 degrees. Is 105 degrees on our unit circle? No. So that one's not going to work. Then maybe I would try 45 degrees minus what equals negative 75 degrees. And that's going to be 120 degrees. Is 120 degrees on our unit circle? Yeah. So we could have rewritten this as cosine of 45 minus 120. So it would work keeping that negative sign in there as well. I think this is just the easy way to think about, because it gets really hard if you're trying to pick both angles at the same time. Just pick an angle, ask yourself what you'd have to subtract it by to give you negative 75 and see if it's on the unit circle. Just kind of trial and error like that. It's the quickest way. And most of the times the ones that I give you will be, you'll check 30, 45, and 60. Usually one of them will work using subtraction. Okay? Other questions? Okay, then we'll go over today's lesson. Today's lesson is notoriously confusing, I guess would be the correct thing. And this really gets down to how you are notationally and how much you understand what actually sine of a value is and cosine of a value is and what this sum and difference of angles are. So we're just going to start out with an example. It says find the exact value of sine alpha plus beta. It wouldn't be hard if they actually gave us the angles. If they were like, this is 35 and this is 60 degrees, that would be fine. But instead they give us that sine alpha equals negative 3 over 5. They give us cosine beta equals negative 1/3. And they say alpha's in quadrant 4 and beta's in quadrant 3. That is all the information they give you. Now, you can't just plug this negative 3 over 5 in for your alpha. Because we know sine alpha equals negative 3 over 5. We don't know what sine of these two angles added together equals. So you can't just plug it in here. And instead, what you have to do is you need to break it down into terms that are sine alphas and cosine betas. And in order to do that, we're going to use our sum of angles identity, where sine of alpha plus beta equals sine alpha times cosine beta plus cosine alpha sine beta. Then what you're going to do is you're going to fill in the information you know about that. Well, we have sine alpha times cosine beta. Well, sine alpha equals negative 3 over 5. So we're going to replace that sine alpha with negative 3 over 5. That's what happened here. Then we have our cosine beta equaling negative 1/3. So I'm going to find my cosine beta. Just to be clear, sometimes they'll give me cosine alpha. All right, there are times where you're filling something in over here. So you have to write it out and then just see what information you are given first. So that's my cosine beta is now going to be negative 1/3. So I plug negative 1/3 in place of cosine beta. Now what we're going to recognize, we're missing two values. We're missing cosine alpha, and we're missing sine beta. So that's what we actually, those are the only two values we have to find. They'll give you two of them in the equation. You just have to find the other two. And we're going to put kind of a shortcut off to the side. So remember the old sine squared plus cosine? Maybe I should put an alpha or something in there. Sine squared x plus cosine squared x equals 1. We remember that, right? I hope. Then we said there's an alteration we can do to it and say, well, sine squared x could equal 1 minus cosine squared x. I'm going to go one step further. I'm going to go one step further and take the square root of both sides and be able to say that sine of x equals the square root plus or minus 1 minus cosine squared x. Now, the only reason why I did this is it shortcuts the problem just a little bit. And we'll talk about how it shortcuts it and how you don't have to use this at all. If you just remember sine squared plus cosine squared equals 1 and you know how to solve it from there, awesome, do it every single time. This is just a slight shortcut. So now we have sine of x equals plus or minus square root of 1 minus cosine squared. All right, for the first method, we're going to use that idea. We're looking for cosine alpha. So you could have cosine squared alpha plus sine squared alpha equals 1. You could say that your cosine alpha is going to deal with my sine alpha. Keep alphas and alphas. So you could take this negative 3 over 5 and plug it in here. Instead, I'm going to kind of shortcut this by saying, well, this is the same thing as cosine alpha equals the square root plus or minus 1 minus sine squared alpha. Well, sine alpha equals, I already forgot what it equals because it's way up there, is negative 3 over 5. So you're going to take that negative 3 over 5 and plug it in for your sine squared alpha. So we're going to have this equals plus or minus 1 minus negative 3 over 5 squared. Well, that's going to equal plus or minus the square root of, I'm going to change my 1 to 25 over 25, minus, well, negative 3 squared is a positive 9, over 5 squared, which is 25, which then equals plus or minus 25, minus 9 is going to be 16 over 25, which is going to equal 4 over 5. Now I just have to decide if that's positive or negative. And where are we going to figure out whether it's positive or negative from? Liv?
Alpha's in quadrant 4.
Alpha's in quadrant 4. So since alpha is in quadrant 4, you have all students take calculus. That means cosine must be positive in quadrant 4. So it's going to be a positive 4 over 5 because we are in quadrant 4. Don't get confused with this shortcut. If you want to, you can take that negative 3 over 5 and plug it in for your sine here and solve it like you normally do. All right, this just cuts off a little bit of time off your solving process. All right, another one is looking for sine of beta. So you're going to look back up at your original problem and see what beta has to do with it. Well, it says cosine beta equals negative 1/3. So sine of that, well, cosine of beta equals negative 1/3. So we're going to use the fact that sine of beta is going to equal the square root of 1, is plus or minus 1 minus that cosine squared beta. Well, we know cosine beta is 1 minus negative 1 over 3 squared, which is going to equal plus or minus. So what I do is, I know 3 squared is going to be 9, so I change this to 9 over 9, just to kind of save me some time. And then we have negative 1 squared, which is 1 over 9. That's going to equal plus or minus the square root of 9 minus 1 is 8.
Would it be plus?
Why would it be plus?
Because it's a negative one thing. Oh, no,
But you got to square it. Yep. And it's a very, very common mistake that people make. Very, very common. Make sure you square it first and then deal with your negatives after it. I'll see that a lot on the test. All right, then that's going to equal the square root of 8 over 9. How do I simplify the square root of 8, though? What can I rewrite the square root of 8 as? Maybe I'll write it over here. So we would have plus or minus the square root of 8 over 3, which is going to equal, Liv? 2 times the square root of 2 over 3. Now I just have to decide if it's positive or negative. So we look back up at beta. Beta's in quadrant 3. All students take. Tangent is positive. Everything else is negative. So it is going to be a negative 2 square root of 2 over 3, because we are in quadrant 3. All right, the sine of alpha plus beta equals the sine of alpha times cosine beta plus cosine of alpha sine beta. Now we have all those values. Now we have all of those values. From above, our first two are negative 3 over 5 times negative 1/3. Times negative 1/3. From this one, our cosine alpha equals 4 over 5. And our sine is going to be negative 2 square root of 2 over 3. And going down, negative 3 times negative 1 is a positive 3 over 15. Minus 8 square root of 2 over 15, which is just going to result in 3 minus 8 square root of 2 over 15. All right, questions on that? We're going to do that one more time. All right, this one says, find the values of cosine alpha minus beta, given that sine alpha equals 1/3 and cosine beta equals negative 1/3. And both angles are in quadrant 2. So the first thing we are going to write is we're going to write out what cosine alpha minus beta equals. Cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. Then we're just going to plug in what we know and what we don't know. Well, we know sine of alpha equals 1/3. And we know cosine beta equals negative 1/3. So we don't know what cosine alpha equals. We do know that cosine beta equals negative 1/3. So whatever that is times negative 1/3. Plus our sine alpha is 1/3. We don't know what sine beta equals. So we really just need to find sine beta and cosine alpha. I'm going to slide this over just a little bit. All right, so the first one we're going to find is our cosine. Let's go ahead and find our cosine alpha. Well, cosine alpha is going to equal plus or minus the square root of 1 minus sine alpha squared. So that's going to be 1/3 squared. Well, that's going to equal plus or minus the square root of 9/9. Minus 1 squared is 1. 3 squared is 9. Which is going to equal plus or minus the square root of 8/9. Which is going to be plus or minus, let's leave that off for just a second. We're going to have 2 square root of 2/3. Well, it terminates in quadrant 2. All students' sign is positive in quadrant 2. Everything else is negative. So this would be a negative. All right, the other thing I need to find is that, what are we missing? We're missing sine beta. So we just need to find sine beta on the next one. Well, sine beta is going to equal plus or minus the square root of 1 minus cosine beta squared. And in this case, my cosine beta equals negative 1/3. So that is, once again, my cosine beta squared. All right, well, that's just going to equal plus or minus the square root of 9/9 minus, now remember, do your square first before you deal with your negatives. This is negative 1/3 squared, so it's going to be positive. It's going to be a positive 1/9. Just like the other one, it's either going to be positive or negative, and it's going to be 2 square root of 2/3. Since we're in quadrant 2, it's going to be positive. Remember, positive and negatives dealt with what quadrant you're in. All right, they gave me 2 values. They gave me sine alpha, cosine beta. I just had to find the cosine alpha and the sine beta, and then we just plug it in this equation. So we said we were missing cosine alpha. Well, we found it. Cosine alpha is negative 2 square root of 2/3. So we're going to have negative 2 square root of 2/3 times that negative 1/3. They gave us that value. Plus 1/3 times our sine beta. Our sine beta was 2 square root of 2/3. Doing that multiplication, we have a negative times a negative, which is a positive 2 square root of 2/9. Plus 1 times square root of 2/2, which is 2 square root of 2/9, which equals 4 square root of 2/9. Guys, if you want to do this well on the test, you're going to write this out every single time. All right, everyone that makes mistakes on this are the ones that just try to do it as quickly as possible, and they try to do everything in their head. On your test, when you get to a problem like this, write it out. In fact, anytime on the test they give you like a double angle or a sum difference angle, just write it out underneath, or make sure you're looking off to the side to know exactly what they're talking about. People that write it this way and show what's missing do this problem a lot better than people that do in their head. People that do in their head usually get it 100% wrong and mess stuff up, and I don't know what they did, and then you lose a whole bunch of points. So as soon as you see a problem like this, just write it out. And like I said, anytime I see a sum or a difference, I'm probably going to write it out, or I'm going to look at something. because we're going to use it to verify. We're going to use it to verify. And like I said, anytime I see this, I'm going to write it out as its identity. I don't care what side it's on. I'm going to write it out as its identity. So that is the side we're going to start with, that left-hand side. Because I'm going to note that this is cosine alpha minus beta, which means I have an identity to write it out fully. And I'm going to take that opportunity every single time. Every single time I see something like this on the test, I'm going to write it out, whether I need to or not, because 99.9% of the time you're going to need to write it all the way out. All right, so we can rewrite this as cosine identity is cosine cosine plus or minus sine sine. So that means we're going to have cosine of our alpha, which is x, times cosine of our beta, which is that pi over 2. And with cosine, it's actually plus. And then it's going to be sine x sine pi over 2. All right, I'm kind of looking at that. And I'm going to say to myself, this is on the unit circle. Pi over 2 is a value that's on the unit circle. Pi over 2 is on the unit circle. What does cosine of pi over 2 equal? What does cosine of pi over 2 equal? Okay.
0.
It equals 0, yeah. So we can replace that with 0, and we can have cosine of x times 0, because that's just equal to 0. Plus sine of x times, well, if cosine is 0, sine must be 1. Anything times 0 is 0, so we're just left with sine of x on this side. Well, that's about as far as I can go on that side. Sine of x is pretty much as simple as you can get on that side. So then you just look at your right-hand side. And you say, okay, this is sine of x, so I need to write all of this in terms of sine and cosine. So when we rewrite cosine, well, I can't rewrite cosine. It's already in cosine form. But I can write tangent as sine of x over cosine of x. And you'll see your cosines cancel out, and you're just left with sine x. The only way you're going to get through this section is to see sum and difference of angles as their alternate form every single time. And that's why I said anytime you see this, write it out. Even if you're not sure what to do, write it out. Because several of you will get to this question on the test and you will not have studied very well the night before. And you're going to be like, I completely forgot how to do this one. But if the one thing you remember is anytime you see a sum or difference of angles and write it out, it might be all you need to remember how to do it. Because as soon as you write it out, you're going to see you have cosine alphas, betas, sines, and you're like, oh, I know those values. I can plug them in. So always write them out. All right, questions for me? All right, then the rest of the time is for you to work. I'm also going to walk around and check your homework that was